In today's lesson, we are going to discuss some algebra questions from SMO2021 Junior section. We start with the first question, which is quite simple. Suppose AB are real numbers, where A less than 0 less than B. Which of the following is not true? We can simply choose some positive B and some negative A to check whether they are true or not true. Let's say we can choose A to be a -1 and B to be equals to 1. -1 squared times 1, that is equals to 1, that is positive. We can't tell whether this is true or not true here. Okay, and for B, this is -1, 1 squared, that is negative. But for C, this is -1 over 1, that is equals to -1, which is negative. Obviously, C is not correct. So the answer should be equal to C. Because for any math statement, if it's true, it must true for all the values. Let's check for the next one. B is equals to 1 and A is equals to -1, that is equals to 2, that is positive. And modulus of A minus B, that is also equals to 2, that is positive. Okay. In fact, A, B, D, E, they are all true not only for the A equals to -1 and B equals to 1. It is true for all the A, B with the condition A less than 0 less than B. Simply because A squared is always positive and B is positive, so the result is positive. B squared is positive, A is negative, negative positive, that is negative. B is positive and A is negative, positive minus negative, it is always positive. And modulus of A minus B is always positive if A and B not the same. In conclusion, C is the answer and C is not true. For this question 3, we are given X, Y, and Z are as such. We need to know which one is biggest and which one is the smallest. As you can see from here, the power is 20 and 5, 5 and 10, and the other one is 10. The common factor of the power is 5. We can consider the power 5. What I mean here is that we can write as something power 5. So this is 3 and this is 2 to the power of 4. 2 to the power of 4 is equals to 16. 16 times 3 is 48. So this is 48 to the power of 5. For second one, take out the 5. This will be 2 to the power of 1 and this is 5 to the power of 2. So this is 2 times 25, that is 50. 50 to the power of 5. And lastly, this is 7 squared. So that is 49. 49 to the power of 5. And obviously from here we can see that Y is the largest and X is the smallest, Z is in the middle. And from the option that we have is at option C. So C is the answer for this question 3. So for this question 5, which of the following is closer to the value of this expression? We have the option A 10, B 20, C 30, 40, and E 50. Now, first we note that 1 over square root of 2 plus 1. If we multiply with the conjugate, square root 2 minus 1, square root 2 minus 1, and we end up with, this is square root 2 minus 1, and for denominator, it is 2 minus 1, so it's 1, that's done. And for second one is square root 3 plus square root 2. Multiply with the conjugate, square root 3 minus square root 2 over square root 3 minus square root 2. And that will be equal to square root 3 minus square root 2. Again, for the denominator, it is equal to 1. And we can probably see the pattern that square root 4 minus square root 3, square root 4 minus square root 3, and it ends up with square root 4 minus square root 3. And we can do all the same until 1 over square root 2021 plus square root 2020 multiplied with the conjugate, square root 2021 minus square root of 2020, square root of 2021 minus square root of 2020, and we will have square root 2021 minus square root 2020. So when we add up everything, many of the terms can be cancelled. And we left with this sum up is actually equals to square root of 2021 minus 1. And note that 2021 is actually equals to 2025 minus 4. That is 45 squared minus 2 squared. So it means that square root of 2021 it will be less than 45 but greater than 44. So this means that this is about 43 point something. And therefore the answer for this is, it is closer to 40. So the answer for question 5 is equals to D. For question 12, we are asked to find the value of square root, the product of 4 consecutive integers plus 1. This is a very standard question asked in SMO for many years. The way to do this is we have to recognize that this is x, x plus 1, x plus 2, x plus 3, then plus 1. And we can combine x and x plus 3. So this is x squared plus 3x. And combine the x plus 1, x plus 2, it is x squared plus 3x plus 2. Then we can let u to be x squared plus 3x. Say this is j. So j will equal to square root of u and u plus 2 plus 1. And this is equal to u squared plus 2u plus 1. And therefore, j equals to square root of u plus 1 squared. Now, if u is positive, then this will be just u plus 1. And u is equals to x squared plus 3x plus 1. That is x plus 3 plus 1. This value j is actually equals to 219 times 222 plus 1. So this is actually equals to 219 times 222 plus 1. After a bit of calculation, 219 times 2, that is equals to 438. 438, 438. So this is 81684. So the answer is 48619. So 48619 is the answer for question 12. For question 15, the question is, how many integer k's are there such that the quadratic equation, this quadratic equation, has only integer solution? Now, first of all, we recognize that when x equals to -1, kx squared plus 20x plus 20 minus k is equals to k minus 20 plus 20 minus k, that is equals to 0. So it means that x equals to -1 is a solution. If x equals to -1 is a solution, it means that kx squared plus 20x plus 20 minus k can be factorized as k plus 1. And for another factor, it will be equal to kx plus 20 minus k. So when you expand it, you will have kx squared, 20x and negative kx plus kx. So we have only 20x and plus 20 minus k. And therefore, x equals to -1 or x equals to k minus 20 over k. That is equals to 1 minus 20 over k. In order to make x to be integer, k has to be a factor of 20. Now, what is 20? 20 is equals to 2 to the power of 2 times 5. 4 times 5 is equals to 20. And therefore, from here, we'll see that they have a total of 3 times 2 positive factors. And they are 1, 2, 4, 5, 10, and 20. These are all 6 positive factors. So k can be either any of these 12 factors. Altogether, 12 integer k, such that this quadratic equation has integer solution. So 12 is the answer for question 15. For question 18, we are asked to find the value of the floor function of this value. There are 2 ways to deal with that. We do the standard way, called the first method. We let x to be equal to square root of 45 plus square root of 2021 minus square root of 45 minus square root of 2021. Then we square both sides. We'll see that, let's say this is a minus b. So it will be a squared minus 2ab plus b squared. A squared is as such. And plus b squared. And also minus 2 square root of ab. That is equals to 45 plus square root of 2021 square root 45 minus square root of 2021. Square root of 2021 will be cancelled off, and we have this is 90 minus 2. We can make it as a big square root. So this is a minus b, a plus b. It will be a square minus b square. A square minus b square. And we know that this is equal to 2025 minus 2021. That is equal to 4. Square root of 4 is equal to 2. 2 times 2 is equal to 4. So that is 86. So x will be equal to square root of 86. Square root of 86 is equal to 9 point something. And therefore, the floor of x will be equal to a 9. So this is one way to deal with this question. And we go to the next possible method. For the next method, we notice that 45 plus square root of 2021 can be written as half times 90 plus 2 square root of 2021. 90 can be written as 47 plus 43. 2021 can be written as 47 times 43. So this means that this is square root of 47 plus square root of 43 square. Likewise, we will have 45 minus square root of 2021 will be quite similar, and it is equal to half of square root of 47 minus square root of 43 square. Then we have square root of 45 plus square root of 2021 minus square root of 45 minus square root of 2021 will be equal to 1 over square root 2. Then square root of 47 plus square root of 43 minus 1 over square root 2, square root of 47 minus square root of 43. So square root of 47 will be cancelled off, and we have 1 over square root 2 times 43 plus the same thing, then we have double of it, that is square root of 2, square root of 43. That is square root of 86. This is the answer that we have previously. So this is equal to 9 point something. And therefore, this answer will be equal to a 9. And this is the second method that I mentioned just now. Question 19. X is positive real number such that square root of x squared minus 4x plus 5 plus square root of x squared plus 4x plus 5 equals to 3x. If so, what is the floor function of 10,000 x squared? So for this, we'll write it as square root of x squared minus 4x plus 5 equals to 3x minus square root of x squared plus 4x plus 5. When we square both sides, this is x squared minus 4x plus 5. And from here, it is a minus b, so it will be a squared, that's a squared, plus b squared, minus 2ab, that is minus 6x square root of x squared plus 4x plus 5. We see that x squared and 5 will be cancelled off. Then we left with 9x squared, and 8x. And everything here move to the other side. 6x square root of x squared plus 4x plus 5. Now note that x equals to 0 cannot be the answer, because when x equals to 0, the left hand side is not 0, but the right hand side is equal to 0. Which means that we can cancel the x. So this is 6 square root x squared plus 4x plus 5 equals to 9x plus 8. We square both sides, then it will be equal to 36x squared plus 4x plus 5. And here will be 81x squared plus 144x plus 64. So from here, that is 36x squared plus 144x plus 180 equals to 81x squared plus 144x plus 64. So 144x will be cancelled off. Then there will be equal to 45x squared, 116. So x squared equals to 116 over 45. So therefore, this will equal to 10,000 multiplied with 116 over 45. After take the floor, it should be equal to 25777. So 25777 is the answer for question 19. Question 20. What is the number of positive integers c such that the quadratic equation has real roots? In order to make the quadratic equation has real root, we just need to consider the discriminant, that is equals to b squared minus 4ac. It must be greater than or equals to 0. C will be less than or equals to 2021 square over 400. So we just need to calculate what is this value here. 2021 can be written as 2000 plus 21 square over 400. So that will be equal to 4,000,000 plus 21 times 4,000 plus 441 over 400. So after the cancel with 400, that is 10,000. After cancel with 400, that is 210. And this will equal to 1 point something. So that will be equal to 10211 point something. And since c is positive integers, so it starts from 1, 2, 3 all the way to 10211. So the number of positive integers c will be equal to 10211. And therefore 10211 is the answer for question 20. So this is the last question for our lesson today. If a is as such, what is the floor function of a over 10? Now we will define another two similar number that is called b. We start with 4, 6, 8 up to 802. And here we have 3, 5, 7 all the way to 801. That is for b. And we also start with 2, 4, 6 all the way to 800. And this start with 1, 3, 5 all the way to 799. So after we have this, then we will see that a times b, 3 and 3 will cancel off, 4 and 4 cancel off, 5 and 5 cancel off, and so on and so forth, until 802 will be here, and 2 will be there, and that is 401. And from the definition of a, b, and c, then we see that a will be greater than b, but will be less than c. And since a is greater than b, ab must be less than a and a. So that is less than a squared. So a squared is greater than 401. A is greater than 20. Next, we'll consider a and c. A and c will cancel 2, 3, 4, 5, 6, and so on and so forth until 800. And what we left here is 801 and over 1. Again, a is less than c, so ac will be greater than a and a, that's a squared. So a squared is less than 801, and it will be 20 plus, but we just say that a is less than 30. From these two inequality, then we will have a is in between 20 and 30. A over 10 is therefore in between 2 and 3. And therefore, the floor function of a over 10 will be equals to 2. And the answer for this is a equals to 2. So what we have today is some algebra question from SMO Junior 2021. For tomorrow, I'll prepare number theory question at SMO 2021 Junior section. That's all for today's lesson. I'll see you again. Bye-bye.